This is the continuation of assembly language notation, whereas we have seen it is categorized into three types, that is one address, two address, and three address. We have seen the three address instruction completely, and for two address we have seen the same instruction will be subdivided into multiple steps. To performing an simple operation, the number of steps involved will be increased in two address instruction, whereas in this it has mentioned add a comma b is the first instruction which we are given here. In this, add a comma b represents, I am saying about add a comma b. In this, add a comma b acts as an source and destination, which as I have shared in to performing c is equal to b plus a plus b operation in down. So b acts as an source and destination. For first instruction, the operation which will be performed is b is equal to a plus b. That is, the contents of a and b will be written and the addition operation will be performed, and it will be the result will be rewritten into the address location of b. This is mentioned here. The sum of the result is calculated and it is sent back to the memory and stored in the location of b, replacing the original contents of the location b, whereas b acts as an source and destination. For that, with this only we have seen, for performing the operation c is equal to a plus b, it involves two steps. First one is move b comma c. Move b comma c, where the contents of c will be copied to where the contents of b will be copied to location c, and followed by add a comma c, where the data of address a will be added to the already copied contents of b is in location c. It will be performed the addition operation and the result will be overwritten into the location c. So the number of steps involved for performing the operation will be increased in two address compared to three address instructions. And finally, this is one address instruction. One address instruction usually consists of only one address location. See here, operation comma whatever the source or destination is the syntax for that. Based on the operation which we are mentioning, the address location will act as an source or destination. Okay, in this for example, what to say, if loading and storing, it can perform only in a single address. For adding and subtraction or whatever the arithmetic operation, it needs to be involved of at least two values should be added, right? In that case, only single address location is mentioned, so we will be using an additional address location known as accumulator for one address instruction. This accumulator is nothing but it is a temporary register which shows the value which we are currently performing the action, and that will be accompanied to perform the operation which was mentioned in that instruction. If we are giving add a, the value of address location a will be added to the former contents of the accumulator, and the result will be replaced on the accumulator only, because here the instruction is given as add only. This means, let us see the explanation below. It adds the contents of the memory location a to the contents of the accumulator register and places the sum back into the accumulator. Okay, this is the operation which will be performed for this respective add a instruction. And load a is the next instruction given as example. In this, nothing but load a is nothing but we will be fetching. Load is nothing but read or fetches the meaning. So the data from address location a will be copied to the accumulator. For example, accumulator will be assigned with the value of address location A. This is it. And store A is the next instruction. Store A is nothing but it stores the accumulator value to the address location of A. That is, the address location A will be assigned with the accumulator value. This is the operation which will be performed for storing A.